Hello Internet! Today I like to continue my talk about the use of GRBL and GCode for desktop or consumer CNC machines. In the last video we covered some important GCode and GRBL topics. Today's focus is on milling circles using GCode and working with the coordinate system. I will show you useful details and we will do some manual GCode programming to get a better understanding of GCode. But I highly recommend my last video, which explains basic GRBL and GCode details or the CNC hardware and software setup. Keep in mind, this is just a demonstration how I do work with GCode on my machine. Be very careful and check your machine documentation to understand the abilities of your machine. Again, we have a lot to cover, therefore let's start. If you saw the previous parts, please skip the setup and jump to 430. When we turn on the machine lists the current GRBL settings on the console. If we use the non-GCode command $G, we can see the current status of the modal GCode commands. For example, G54 tells us that we are using the register G54 to define the coordinates of the work coordinate system origin. To see the current GCode parameters, we can use $# command and see the current position data. To use them, we need to initialize the machine coordinate system to give the machine a reference position. To do this, we use $H command and perform a homing cycle. After the homing cycle, the machine coordinate system origin is set and all further movements refer to this origin. Now we can use the already stored parameters and, for example, move to the safe position stored in the G28 register. Therefore, we use the command G28. Check the current parameter position and see how the machine moves to the position stored in G28. Let's move the spindle to the origin stored in the parameter register G54. Therefore, we use GO, rapid movement, with the command GOXOYO. This moves the machine to the origin of the work coordinate system stored in G54. If we want to prepare for a later milling operation, we can already use F800 and S10000 to set the feed rate to 800 mm per minute and a spindle speed to 10,000 revolutions per minute. Since these are modal commands, the machine remembers the states until you turn the machine off, and you can change the values at any time. Now I set the tip of the milling bit to the surface plane by moving the Z-axis in smaller and smaller increments. When I'm happy with the level of the router bit, I just can save the Z-axis height or the complete X, Y and Z coordinates in the G54 register using G10, L20, PO, XO, YO, ZO. This uses the current position and stores it in the G54 register. The L20 parameter takes the current position and the PO and P1 parameters reference the G54 register, where PO references the default register and the P1 parameter references explicitly G54. The machine is in absolute positioning state G90, and we need to use absolute positions in the code to tell the machine where to move. Look at the sketch and compare it to the G1 commands here. Alright, let's get things set up before we start milling a circle with GCode manually. First up, we need to choose a new starting point for our coordinate system. To do that, I'll move the router to a safe spot using the GCode command G28. Then I'll use the command $# to check out the current settings or parameters, including which coordinate system we are currently using. For example, G54 to G59. To switch to a different work coordinate system, we just need to use its G-code, and therefore we can type in G54 or, for example, G55. This will switch to the new work coordinate system. Right now we are using G54 and working on the XY plane in metric units with absolute positioning mode. The router is off and we are not using any coolant. Our feed rate is set to 800 mm per minute and the spindle rate is currently 0. But we want to use the G55 register now. So I'll slowly move the router to the right spot on the workpiece. Once the router is in position, I save the current X, Y and Z position in G55. With the GCode command G10, L20 and P2 as the parameter for the register G55. This will store the current position of the router in the G55 register. Now let me show you how we can use different coordinate systems. Since we are still using G54, if I type GOXOYO, the router will go to the position we set for G54. But if we switch over to G55 and type the same thing, the router will go to the position we set for G55, as you can see here. Now we are ready to continue and milling our circle. Just a note on my behalf before we continue: if you want to support the channel, smash the like button, or if you're a new viewer, subscribe to the channel. Thanks in advance. Here is how we can use GCode GO2 to mill a circle with 10 mm radius using absolute positioning mode. GRBL GCode GO2 is a command that tells a CNC machine to mill a circle in a clockwise direction, and GCode GO3 to move in counterclockwise direction. We will be using absolute positioning mode G90, which means that we will specify the exact coordinates of where we want the tool to move to. Before we start with the milling job, we have to prepare the machine settings. Therefore we have to set the spindle rate using S10000 and set the spindle rate to 10,000 revolutions per minute. Also we have to prepare the feed rate and we set this to 800 mm per minute. M3 will then turn on the spindle, and because I decided to move to a different starting position, I raised this axis to the absolute position set 10, and then I move to the starting position at XO Y15 using the GO1 command and use the feed rate. From this starting position, the milling process, and because I want to go 1 mm deep into the material, I move to the position set -1. And from here we can start milling the circle. My first endpoint will be at X10 Y25. Since the radius is 10 mm and we are starting at XO Y15. The CNC machine will then start moving the tool in a clockwise direction to mill the arc with 45 degrees. Once it reaches the endpoint, it will stop and we can proceed to the next position, which is X20 Y15, and again it mills an arc with 45 degrees. Finally, we will use another GO2 command to mill the last arc with 180 degrees back to the starting position, which is XO Y15. The CNC machine will move in a clockwise direction again, milling the circle or arc until it reaches the endpoint at XO Y15. And finally, I move the axis of the router to the absolute position Z10 above the surface of the material and turn off the router using the GCode command M5. Here's an overview of the commands that I use. In the previous session, I also set the into the register of G56. Therefore, I can now switch to the new coordinate system G56 and can easily jump to the new position. I can now move to the new work coordinate system origin using rapid movement and the coordinates XO and YO, and it will use the position stored in G56. Have a look at the parameter listing in the console window. In the next example, we will mill the same circle with 10 mm radius from a different work coordinate system origin, using the same endpoints for the parts of the circle, or let's say the arcs. But this time we are set the radius as a parameter using the R parameter and not the center point of the circle as parameter. I need to tell the machine a specific absolute coordinate endpoint where the arc should end and the radius of the arc based on the current working coordinate system. Again, we have two 45-degree arcs and 180-degree arc with a radius of 10 mm. Here is a summary of the processing steps for this circle using the radius parameter with GCode GO2. In the final demonstration, I show how we use the GO2 command using relative or incremental positioning. We define the endpoint of the circle or arc using relative positioning with the current position as reference position. This is the only difference. The use of the radius parameter or the center point parameterization for GCode GO2 is the same. And it works in the same way for GO3. Here I move the Z-axis of the router to a milling depth of 2 mm, still using the absolute positioning mode. Then I change to relative positioning with the GCode command G91 in combination with the GCode GO1 or GO2. All coordinates are then relative steps, referred to the current position. The circle has the same number of arcs as in the previous examples. The only difference is the relative positioning. Always make sure whether you are in absolute or relative positioning mode, because if you confuse the modes, you can easily break a piece or damage the machine. After the milling is done, I move the router to a safe set position and turn off the machine. In many cases you will see that the axis is moved to a coordinate saved in the register G28, because the register can be used to store the safe position values for the CNC axis. Again, that's it for today. I hope this helps you to get a better understanding of how to program GCode. I think we covered a lot, and if this video was helpful for you, smash the like button to make the video more popular. This helps me a lot. I will provide more video related to CNC programming and CNC processing in the future. And you can subscribe to stay up to date. You can also add a comment in case you have questions or if I can improve my videos. Let me know. Okay, that's it for today. Have a good time. Thanks for watching. Bye. Free time.